So in example number 7 here, we're converting y equal x squared to polar coordinates. So here's our conversion equations. And I see here that y is r sine theta and x here is r cosine theta. So we can introduce r and theta by just substituting. Y is r sine theta. And then x is r cosine theta. And that guy gets squared. So r sine theta is equal to r squared cosine squared theta. And then we'd like to solve for r, get r in terms of theta. So we can divide r off of both sides. And r should never be 0, so we can do that division. So sine theta is equal to r cosine squared theta. And then divide both sides by cosine squared, and we have it. So cosine squareds cancel here, so r is sine theta, divide by cosine squared theta. So, and there are some other forms that we could write this in. So for example, we could write this as sine theta over cosine theta times 1 over cosine theta. So sine over cosine is tan theta. And then 1 over cosine is secant theta. So it's actually secant theta tangent theta. So this is more complicated in polar coordinates than it is in Cartesian. And that makes sense because it's not something that's round like a circle. Okay, it's a parabola. So, well, you should be able to try problem number 5, either changing from Cartesian to polar or from polar back to Cartesian.